So, how's it going, class? It's your professor here. So, I want to talk today about understanding data storage. So, the objectives here is to normalize a database, understand primary, foreign, composite keys, understand clustered and non-clustered indexes. So here you're gonna your objective domain description, understand normalization, understand primary and foreign composite keys. That's very important, and understanding indexes. So normalizing a database. So normalizing in a nutshell is the elimination of redundant data. There are 5 normalization forms, NFs, and we'll discuss the first 3. Your number 1, NF, eliminating repeating groups. Number 2, NF, eliminating redundant data. Number 3, NF, eliminating columns not dependent on key. Number 4, NF, isolate independent multiple relationships. Number 5, NF, isolate semantically related multiple relationships. So first normal form, 1NF, eliminate repeating groups. The first normal form, 1NF, means that data is in an entity format, which basically means that the following 3 conditions must be met. The table must have no duplicate records. The table must not have multiple value attributes. The entries and the columns or attribute are of the same data type. When you define a primary key, you have met the criteria for 1NF. So second normal form, 2NF, eliminate redundant data. The second normal form, 2NF, ensures that each attribute does in fact describes the entity. It's entirely based on dependency, and that the attributes of an entity in question, which is not part of the candidate key, must be functionally dependent upon the entire primary key. So if an attribute depends on one of the primary key attributes but not the other, then it becomes a partial dependency, which violates the second normal form. So third normal form, 3NF, eliminate columns not dependent on keys. The third normal form, 3NF, checks for transitive dependencies. A transitive dependency is similar to a partial dependency in that they both refer to attributes that are not fully dependent on the primary key. So a dependency is considered transient, and when attribute 1 is dependent on attribute 2, which is the dependent on primary key. So fourth normal form, 4NF, isolate independent and multiple relationships. So the fourth normal form, 4NF, involves 2 independent attributes brought together to form a primary key along with the third attribute. But if the 2 attributes don't really uniquely identify the entity without the third attribute, then the design violates the fourth normal form. So fifth normal form, 5NF, isolates semantically related multiple relationships. So the fifth normal form, 5NF, provides the method for designing complex relationships involving multiple, usually 3 or more entities. So satisfying the requirements of the third normal form is usually enough. When looking at the fourth and fifth normal forms, they may be complex, but violating them can cause severe problems. So there are 3 different types of constraint available within the SQL Server that will ensure you are able to maintain database integrity: primary key, foreign key, and composite unique key. A unique constraint key allows you to enforce the uniqueness property of columns other than the primary key within the table. The primary key, perhaps the most important concept for designing any database table, is that it has a primary key, an attribute or set of attributes that can be used to uniquely identify the row. Every table must have a primary key. Without a primary key, it's not a valid table. By definition, a primary key must be unique and must have a value which is not null. Foreign key, when you have 2 tables relating to one another, one of those tables will act as a primary table and the other will act as a secondary table. In order to connect the 2 tables, the primary key is then replicated from the primary to secondary table, and now all the key attributes duplicated from the primary table are now known as the foreign key. Composite primary key. It's very important to know what kind of keys you're talking about. A composite primary key occurs when you define more than one column as your primary key. Although many database admins do not use them, nor do they sometimes even aware of them, they play an integral part in the designing of a good, solid data model. So indexes, right? You guys want to have a fast index because that's how applications are thriving. Indexes allows you to access data faster. There are 2 types of indexes: clustered index and non-clustered indexes. So clustered indexes, each table can have only one clustered index that defines how SQL Server will sort the data stored inside the table. Cluster index is a physical construct as opposed to most indexes, which are logical or software based. So non-clustered indexes You have the freedom to create your own non-clustered indexes. They have a structure separate from what is found in the clustered index structure. This is because a non-clustered index contains the non-clustered index key value, and each of those keys has a pointer to a data row which contains the key value. So this pointer is referred to as a row locator, and the locator structure depends on whether the data pages are stored in a heap or as a clustered table. So summary, normalization in a nutshell is the elimination of a redundant data to save space. The first normalized form, 1NF, means that the data is an entity format, which basically means that the following three conditions must be met. The table must have no duplicate records. The table must also not have multiple value attributes, and the entries in the columns or attribute must be of the same data type. So the second normal form, 2NF, ensures that each attribute does in fact describes the entity. So let's go ahead and recap. The third normal form, 3NF, checks for transitive dependency. A transitive dependency is similar to a partial dependency in which they both refer to attributes that are not fully dependent on the primary key. The fourth normal form, 4NF, involves two independent attributes brought together to form a primary key along with the third attribute. The fifth normal form, 5NF, provides a method for designing complex relationships involving multiple, usually three or more entities. There are three different types of constraints available within the SQL Server that will ensure you are able to maintain database integrity: primary key, foreign key, and composite unique key. A unique constraint key allows you to enforce the uniqueness property of columns other than a primary key within the table. So perhaps the most important concept of designing any database table is that it has a primary key, an attribute or set of attributes that can be used to uniquely identify the row. So every table must have a primary key. Without a primary key, it is not a valid table. By definition, a primary key must be unique and must have a value which is not null. In order to connect two tables, the primary key is then replicated from the primary to secondary table, and now all the key attributes duplicated from the primary table are not known as the foreign key. A composite primary key occurs when you define more than one column as your primary key. The only real drawback is using indexing, or the time it takes to build the actual index and the storage space required for the indexes. When you begin looking at implementing indexes, it is important to remember that each table can only have one clustered index that defines how SQL Server will sort the data stored inside the table, because the data can only be sorted in one way. A non-clustered index contains the non-clustered index key values, and each of those keys has a pointer to a data row that contains the key value. So here we're gonna go ahead and recap. We did our recap. We go ahead and talk about, go ahead and implement that on your projects. And I want you guys to remember some of the things that we went over. All right. So understanding data storage. Hope you guys have a great weekend. And this is your professor. Thank you.